questions come through. You're going to ask for questions?
One more.
Yeah, absolutely. Evening, the last session of the day, and I think it's a very interesting topic. I think they'll get into a lot of detail of stuff that'll be most interesting. Dr. Tim Farrar is going to do the moderating of this panel, and I'm going to hand it over to Tim. Thank you very much, Tim.
Thanks, Silvano. I know we're the last panel of the day, and we're all sitting between you and your drinks parties, so I apologize for that in advance. Hopefully we will keep it lively and enjoyable, and I would welcome questions. Do feel free to submit those through the app, and we'll see what we get to. But I know we've got a lot to discuss, and we've only got 45 minutes to do that. So without further ado, I'm just going to ask people to briefly introduce themselves, and then we'll jump straight into questions. So Clemens, let's start at that end.
Yeah, Clemens Kaiser, CPO, Chief Program Officer of Rivada Space Network. So I'm responsible to get this constellation on track we plan to build.
Randall.
Randall Barney, Director of Certification and Membership for the World Teleport Association.
Ron van der Breggen, Rivada Space Networks. I head up the commercial organization as Chief Commercial Officer.
Yeah, and I'm Larry Paul. I'm Vice President of Corporate Business Development at Inmarsat in London, but I'm in DC.
And Mike Abad-Santos, I'm the CEO of BridgeComm.
Great. So thanks very much and welcome, all of you. This panel is about turning constellations into networks and the future of LEO satellites in a networked environment. You know, obviously the big thing towering over the whole satellite industry is the success of Starlink, and I think it's really helpful to understand how new entrants like Rivada are going to differentiate themselves. But to start with, I mean, maybe I'll just turn to Larry. I mean, what do you see as someone who's been in the industry a long time as the areas of success for LEO, and particularly what Starlink's done, and what do others need to do to differentiate themselves? How's Inmarsat approaching that, for example?
Yeah, so I mean, first I'll say congratulations to Starlink. I mean, they've totally turned this industry on its head. I don't think there's many of us in here, if we were totally honest, would have said we saw that coming the way it came. And what I mean by that is the speed at which they built their network, the pace they went at, the try and fail and try and fail and iterate and fail and iterate and fail until you get it right. And there's a lot of capacity out there. They've got 27 terabits of capacity in space right now. It's doubling every 18 months, as I understand it. But so it's the pace at which they moved, and also they started with the terminal. So a lot of satellite manufacturers or satellite operators, including ourselves, traditionally spec a spacecraft, procure a spacecraft, get the contract going, and then they start thinking about the terminal. What Starlink did was they thought about the terminal first, the user experience first, and I'm not the smartest guy in this room, I know that, but I think I could probably set one up.
Yeah, great. I mean, Clemens, maybe you can just introduce a bit to the Rivada system and what you're planning there, and how you've approached the design of that network.
Yeah, thanks. The interesting comparison between Starlink and us is we are only 10 days apart in the filing database of the ITU, 2014. Yeah? So our founders, long ago, were 10 days faster than Starlink. And it's interesting to see now, and it has all my respect, what Starlink did. The interesting thing is now looking back what we want to realize and compare it with our competitors, and Starlink, of course, is a competitor. We are addressing a completely different market segment, and I think this is a differentiation. I always say not everything which has 4 wheels is a car. Sometimes you have a lorry or a bus or whatever, and the architecture was indeed already 2014 thought through and designed to be a network in the sky. Although this technology was not yet there in 2014, yeah? And therefore we are realizing now something which was planned already 9 years ago, and it has exactly the right size. We are only 600 satellites, yeah, 2 times 300. We have 2 filings. Yeah. The satellites are not very big. These are not monster satellites. The point is that this high throughput application, and I think we will talk about more, allows you a complete different design on both sides, the ground segment and the space segment. And I think what I see now as an engineer was really a good choice to make also, to pave the way to realize it realistically on the space and the ground segment end.
Great. Mike, do you want to weigh in on the sorts of developments you've seen and how your technology is going to fit into these new networks and how you're going to address this sort of new competitive environment?
Thank you very much. What we are seeing is a large demand for, we're human beings, right? So we want to be able to communicate just like we are in our home, whether or not we're on a car, a plane, a boat, et cetera. And for government applications, it's absolutely the same. They want to be able to operate as if they're, on their home base. So what we are seeing from, a component side or the optical intersatellite link side is a desire for more mesh networking, more interconnectivity between the various domains in order to satisfy those demands. And that's why these multiple domain, multiple orbit architectures are very interesting to us.
Great. And Ronald, I mean, we're in a much more difficult financially challenging landscape than we might have been, a couple of years ago in terms of, money being available for these new systems. How do you, how do you take that into account in terms of building the finances for your network and getting those commitments? Is it about anchor customers? Is it about, presumably you don't have a billionaire or a centibillionaire behind you, so where's the money going to come from?
Well, at the end of the day, it's a great question, because at the end of the day, it's coming from the customers, and Starlink was mentioned earlier before, and so that is something I think that also differentiates us there. I've been in NGSO systems for quite a long time, and on the record, almost equally long, for saying that in this industry, we seem to be chasing the last mile. And so this industry is all about the last mile, connecting somebody who does not have any connectivity and making sure it connects into either the internet or some VPN or a cloud system or whatever as soon as possible. So we're using very expensive infrastructure to connect into a cable system. So I've always said, if you have this expensive infrastructure, it makes a lot more sense to keep the data in the system as long as you can, only for it to exit the system right at the point where you need it to terminate. And I've used many ways to explain it. Put it in a historic perspective, talk about the architecture, talk about the business plan, analogies left, right, and center. And so yesterday we're talking with somebody about Colt. I don't know if you know what Colt is. Colt Telecom is a London-based company. You know that. And for some of you that know the company, you may not even know what the Colt stands for. It stands for City of London Telecom. Exactly. So back late in the late 90s, if you were a large carrier and you wanted to terminate circuits in London, you had to go to somebody to actually do that for you, because you had the long haul, but you couldn't terminate anything in London. So you could go to British Telecom, but they had inferior technology relative to Colt, who was brand new and had the latest and greatest. So Colt, meanwhile, is a company that is branched out worldwide, has got big backbones, and is all around and everywhere. And so they have developed the company not in terms of doing more London things. There is no, they didn't go to City of Trenton Telecom and then City of St. Louis Telecom. No, they built their network, they made it international, and they got customers on there that they could carry from the very beginning to the very end, and this is what Colt Telecom is nowadays. We're doing exactly the same. In the terrestrial world, we've seen that doing only local tails, or last mile as we call it in satellite, is a business model that involves very expensive equipment, i.e. satellites, and so therefore the better use is to enter into a market where it's not about providing a service that can be easily copied by others, as you see in the local tail business, but to create a service that is unique relative to others. And this is exactly what we're doing here. So we're picking up the customer's traffic, you put it on the satellite system, and it can go anywhere you like. So back to your question, where's the money then going to come from? If we talk to our customers, then we talk to many customers that are outside of the satellite industry. We talk to a pharmaceutical who says, we've never considered using a satellite, simply because, you know, there's no use for it, it's too expensive, it doesn't get me the performance that I want. But with these types of configuration that you guys are setting up, with the architecture that you have, we will consider satellites. So I always chuckle a little when I got a great respect for Chris Bow from NSR and from some of the other research companies like Euroconsult, when they talk about the satellite market and how much money is in there and how much capacity is in there. And I keep saying, I'm saying it for a long time, our market, if we configure our satellites a little bit better and a little bit, let me say, professional in terms of the professional services that we can offer, our market, in fact, is a lot bigger. So where the money is coming from is from these customers that have more serious problems than, oh, I have this last office that I need to connect and I only want to pay the lowest possible price. We talk to customers that we got real problems with cybersecurity. We got real problems with latency. We got real problems with running ERP systems in a large wide area network. We got real problems with command and control applications that we cannot get to work using multiple cable systems, and we need the shortest path through space. Those companies have these real problems. They have real budgets to solve those problems, and we can tap into these budgets much better than any satellite system can, including Starlink, and including terrestrial systems.
But just to be more specific, when people say the money's coming from the customer, what they usually mean is, I'm going to get some contracts and I'm going to export credit agency and they're going to finance my system. It's not that the customers are going to pay upfront or become investors in your system,
Correct.
presumably. Okay. Mike?
The only thing that I would add to Ronald is that we're seeing a convergence in capabilities in terms of what's available terrestrially and what's available through space. And, you know, I started in telecom probably as long ago as most of the people here, and I remember selling 2.4 kilobit per second systems. Terrestrially.
600 baud, Inmarsat.
Well, so I started at PSINet, then I went to Inmarsat selling 2.4 kilobits per second systems, and now we're talking about gigabits and potentially terabit link systems. So what we're seeing is this convergence of terrestrial and space. Now, I think one of the challenges for us on the space side is, can we drive the cost down of the space parts of the link to make it completely seamless? Again, the ultimate goal is people don't care about what network they're on. They don't care about whether they're going through space or whether they're going through a fiber optic or cable channel or a Cat 5, Cat 6, whatever. They just care about whether they can create their data and whether they can distribute their data and whether they can consume their data. So as we see more of this hybridization between space and Earth and then eventually air, et cetera, that's the ultimate goal for what I think we're trying to architect here.
And Randall, I'll come to you. I mean, where do the teleports fit into all of this? I mean, we've had huge numbers of gateways deployed by systems like Starlink, and OneWeb's getting its gateways up and running. How do you fit into this new ecosystem of sort of networks? Especially when we're talking about some systems like Rivada's, which I think is more of a gateway-less network. What's the role of teleports going forward?
Well, teleports represent some high-end real estate. Aside from the real estate, they are very established, robust systems and are ideal places to co-locate gateways. Some already are, and the ground station as a service providers are helping move that along for the constellations.
Yeah. But so, I mean, do you see that the providers, some of these people like Amazon are getting into that gateway business themselves, and is the role for independent teleport operators, is that a sustainable one, or is there going to be vertical integration into the teleport side as well?
It is sustainable. I believe through partnerships, they will continue to go on and provide high quality services to their customers, but I think there'll need to be some more collaboration.
Mm-hmm. And so, Clemens, I'll come back to you. I mean, it sounds great to integrate all these networks at the customer site, but obviously those customers are going to have some user equipment there. So, I think Larry pointed out that, that was one of the great advances that Starlink has made. It's a path that Amazon's also following now as the other, player that's got tens of billions of dollars potentially to invest. So how do you measure up on that, and what thoughts have you had on, do you need to compete with them on a cheap terminal? Do you need phased arrays? What's your user equipment going to look like at the end of the day?
Yeah, thanks. Indeed, we are talking here about a phased array antenna also on ground. Yeah? There are maybe, can do it maybe with a parabolic steerable thing, but I would say the tendency is really a parabolic phased array antenna on ground. Indeed, when I started some years ago this project, I had put all my energy really on bringing the space segment alive, but I always had in the back always the threat of, okay, I have a ground segment to develop and user terminals to develop. This was indeed originally the plan. But now if you look around, obviously the market which is ahead of us is so huge that a lot of vendors which are in touch with have already entered into this path. If I go around, it's more for us a customization of existing products which are currently under development, or what we are doing currently with, I would say, potential customers which are speaking with us, how can we integrate their ground equipment into our system? This is a lot of engineering work, a lot of things, but we see already that our system, I would say, fits into it. Yeah? It's maybe due to the specific applications we have. Yeah? We are not talking about small antennas for autonomous driving or to handheld. Our system with a high throughput capability requires, of course, a larger terminal on ground. Yeah? But these have also other systems. A lot of synergies here, and we are just starting now with the space segment on its track to get also this running, and we are quite sure that if we launch the first satellites in 25 and have the first planes there to interconnect end of 25, that the terminals will be there.
But I mean, what I think one of the challenges for me is is the traditional model still going to apply? Are you confident enough that you can go to a traditional vendor like a Thales or an Airbus and build the satellites? Are you confident that you can go out and have your choice of user equipment vendors? Because, SpaceX is moving very quickly. Amazon has decided to build its, design its terminals in-house, build its satellites in-house. What do they know? What are they doing differently? And why do they think that they have to go that way? And can we have confidence that sticking with the traditional model is the way forward?
Well, it's there. This high vertical integration is their decision. I mean, it comes. I'm honestly, we go it a different way, and I'm convinced, and we are convinced, this open system allows us much more to interface with other systems and integrate it with other systems. We see our real added value in running the network and the services. We completely procure turnkey system as a satellite. We will select, of course, also the components, and we help to get the right payload on board. But our objective is not to become another satellite manufacturer or something. I think we have enough around worldwide. This is not what we want to achieve. We want to procure stuff, plug it together, and make the intelligence control into the system that we can drive the service.
Yeah, I mean, Larry, Inmarsat's got its own LEO ambitions for the future.
Well,
I mean,
yeah, two things. First, I just want to say, there's only so many Amazons and SpaceXs in the world. We don't all have the luxury of of not having to worry about return on investment for 10 or 15 years. Let's face it. So I think the approach you're taking makes a lot of sense. What we're being demanded, what our customers are asking for is a proliferated, multi-frequency, multi-orbit space segment. When I say our customers, this is primarily the US government. It's other governments as well. But if the governments, if the governments are, I got a big flash up here. If the governments, it's the governments that drive innovation and change, and it's often the commercial markets that then follow. So what we're doing now is we are an operator of GEO L-band satellites, GEO Ka-band satellites, GEO Mil-Ka payloads on the satellites. We have S-band at GEO in Europe. We are launching, starting at the end of this year, hopefully, we're putting payloads on 2 highly elliptical orbit satellites to provide Ka-band over the Arctic. And we're going to stitch this all together with coastal LTE, which is what we use today to provide service to our maritime customers. We're developing a 5G mesh network to fill in hotspots, the Straits of Singapore, the South China Sea. And we are going to add a LEO component. One of the speakers earlier said that Inmarsat did not have a LEO strategy. Well, we do. We took a hard look at building our own, becoming a major investor in others, and it just doesn't make sense at this point for us when our customers want this proliferated network. We don't have the balance sheet to support that kind of investment. So we're going to partner with a LEO operator, maybe more than one. And then we're going to tie it all together with what we're calling Orchestra, which is just, we got some clever marketing people. It's really just a software, well, a hyper-intelligent software-defined WAN that will unify all these diverse networks into a common user experience for our customers, and will route traffic over whichever asset will deliver it with the best quality based on the application's requirements and the user requirements. So that's where we're going. It's a bit of a change for us, but we can't own everything, and if you try, you're going to fail. So we're going to find strong partners to work with and pull together Orchestra with the SD-WAN being the conductor. That's kind of a bad joke, but it's our marketing people. That's the way they did it.
Yeah, Mike, I mean, you're obviously going to be a supplier in this sector. You've got to compete with the sorts of volumes that some of these players like Starlink and Amazon are working at. How do you feel about the sustainability of that independent supply chain?
Well, if I was to go back to the previous question before I get to this one, the verticalization of SpaceX and Project Kuiper, et cetera, I think is actually a very good thing for the growth of the space industry in general, because we've seen a little bit of, well, maybe more than a little bit, a lot of stagnation from the prime integrators and a lack of adaptability, a lack of innovation, and I've been on the user side of this at times as well, a lack of listening to what the users are actually demanding. And so, a lot of the people who are here today in this new space economy are innovating at a much more rapid pace than these old primes. Or well-established primes, excuse me. So I think that this is a good thing for the space industry. In terms of, how companies like BridgeComm and others who are focused in the component level or the hardware level, we have some really interesting technology that allows us to take advantage of scale that already exists, right? So one of the prime components of the BridgeComm optical system is a liquid crystal switch. Basically, all these panels here that you see that are TVs, right? So we've adapted that to laser communications. We think that combined with the hundreds of billions of dollars that's been spent on terrestrial infrastructure and advancements in fiber optics, we're taking advantage of those cost benefits now and the scale that's been created in those industries now. We can buy a 100 gig SFP for $15. So, at the end of the day, we think that this is going to be very easily scalable using a lot of COTS equipment. And the other advantage that we have that we didn't have 10 to 20 years ago is the refresh rate of these satellites, right? Back in the geo days, you know, at Inmarsat, we were on a 7 to 10 year tech refresh. It took us 14 years to build the satellite. It took us 15 years to get to FOC. And now we're talking about, you know, 2 to 5 year refresh rates of hundreds of thousands of satellites. So I think all of those are going to be drivers for innovation, focus on cost and focus on capability.
And Randall, I mean, how is that faster pace of development really impacting the decisions of the teleport operators? I'm sorry. I mean, everything's moving so fast, as Mike said. You know, what do teleport operators now need to do differently? Do they, you know, to support all these new constellations and to, you know, support this sort of increased pace of development?
Well, I mean, oh, sorry. They've already started, you know, to try and put themselves out there to be partners with the new constellations. And some of them have already started. Speedcast, for example, is working with Starlink, and now putting Starlink on cruise ships. And when Starlink is working and things are great, then it stays with Starlink. And when that starts to be contended, it'll fail over to a geo circuit. But I think we'll start seeing more proactive and partnerships like that.
Great, and yeah.
And if I can add to that, so we're definitely, because you used the word earlier that sometimes scares teleports, and I've had that discussions with them when you say gatewayless, and so then the first response is, oh, so you don't need us anymore. And that's a joke because they were the ones reaching out to us first. I want to understand that better. And then when you tell the story about how, coming back to the title of this session, turning constellations into networks, when you explain that they go from an operator of antennas to support satellite systems to now become a manager of multiple antennas that sit on rooftops of buildings of enterprises in their region. So they're not focusing so much on the piece of land or the 20 acres they have in front of their headquarters, but they really cover an entire region where, you know, multiple enterprise customers and government customers are making use of networks that, you know, go either into the ground or with Rivada, hopefully soon, go up in space. Then this is where teleports have an enormous value, helping these types of enterprises out with the new systems that they have on their rooftops in this case. And so it's an enormous opportunity for these teleports to now become part of a different satellite system that comes with these new opportunities. So teleports are actually, you know, many of them we're talking to and will be part of the ecosystem that Rivada is planning to put out there in terms of resellers and system integrators.
Larry, did you want to?
Yeah, I just wanted to comment real quickly. Ronald mentioned the gatewayless architecture. It may not be something teleports like, but as a company that provides a lot of services to the government, we love it. We think the gateway's network is ideal from a security point of view, as well as many others, but the big one from a security point of view, if you've got a user in the field who uplinks to, well, we use the Rivada satellite, since you have intersatellite links, or you will have intersatellite links, and you can pass that from spacecraft to spacecraft to spacecraft, and then terminate it on the customer premise, a secure customer premise, it instills a lot of confidence in government and other end users who have high security requirements.
Yeah, and you terminate it on that premise with antennas that the teleport operator in the region is managing, then that makes for a whole new business model. But you're absolutely right. This is one of the positive feedbacks that we're certainly getting, the whole security aspect, definitely.
Mike, did you?
I was just going to add that from an optical perspective, teleports are extremely important for us. And as Randall said, you know, it's all about prime real estate. And for optics, we need a lot of clear sky if we want to deliver, you know, a high uptime network. So, you know, we are very focused on you know, how we can expand our ground systems rapidly in order to accommodate everything that's going up into space.
Yeah. I'll just say, audience members, if anyone's got any questions, please enter them on the app. I'll be happy to get to those in a minute. Let me just pick up on something Larry said first. I mean, you talked about this sort of smart switch, to allow you to mesh together different networks. And I mean, I think that's one of the interesting things to me that I don't think is very widely appreciated. Is there's quite a difference between people saying we need a single terminal that operates with multiple networks and saying multiple terminals can be tied together by a smart switch. So Inmarsat, I mean, I guess your position is you don't necessarily need a single terminal. You can do a lot of what you need to do at the switch level.
We can do a lot of what we need to do at a switch level, but a multifunctional terminal would be beautiful. It would make life a lot easier for everybody. It would be better for the customer experience. If you had a terminal that could operate at L-band GEO, Ka-band GEO, Ka-band LEO, MEO, whatever you want to throw in there, as well as potentially operate over terrestrial networks, depending on what type of situation you're in, it would be great.
It would be great if pigs could fly too. I mean, look, I mean, Inmarsat had that choice for GX, and you didn't build L and Ka together because it didn't make really economic sense.
It did not at the time.
And I don't know where where's the economic boundary here as well.
Well, I'm the wrong person to ask because I'm not a terminal manufacturer. I think you need to ask the terminal manufacturers.
I think one of the big changes that's occurring is the scale of production again. So, we're looking to add more people in. When I was at Inmarsat, terminal manufacturers didn't want to talk to us unless we were building, we're going to put an order in for 10,000 terminals. And now the number is like, tens of millions of terminals. So I think that'll drive innovation, but again, the cynic in me goes back to, back in the DoD days, we had this idea of the joint IP modem, where one modem can talk to every satellite out there. And there's so many economic disadvantages to that it makes it difficult, right? Because everyone wants a closed network to ensure revenues.
Right. Clemens, I mean, how does Rivada think about that sort of dichotomy between the sort of integration at the terminal level versus integration with the sort of smart switching that allows you to move between multiple networks seamlessly?
No, I think we have really, we try to capture our system really from the pure network perspective on a very abstract level. We have nodes. We have nodes in the sky, we have flying routers, we have the nodes on ground. So first of all, it's a network. So we have also, therefore, from the network, we need, first of all, the modems. The RF link, this is just something then to implement it. And therefore, this MPLS system we want to establish may help us here, to establish interfaces which can, on the pure network level, easily connect it together. And this is a bit the point, which is a big advantage now, that if you purely remain on the network layer, then you can route your traffic accordingly. And then, of course, implement the technical means to transport the stuff. But this is a bit the approach and the advantage we also have. And this means, coming back to the customer perspective, what was meant before, the customer will maybe not even see which kind of system is used. It's a point-to-point connectivity using any type of network. And this is a thing we discuss at length with our mother company coming from the terrestrial world and terrestrial communication world and wireless world. And here I see a lot of synergies, and it's just the next step. While we consolidate the different shells, maybe, I think the next big step is then to cooperate here with the terrestrial operators. And I'm quite sure in maybe 10, 20 years, we have a lot of satellites flying, a lot of network, but at the end it's one system which can be interconnected and is interoperable.
Mm-hmm. And just to pick up on, you talked at the beginning about, your filings date back to very similar times to when SpaceX made its filings. Can you talk about your spectrum plans and you don't have, you're not in the processing rounds in the US, as I understand it. Where are you going to be able to serve? Are you going to have access to the US market going forward? And, how do you plan to negotiate that? I mean, Mark Dankberg talked earlier today about, is there enough carrying capacity left in space for a new entrant to even break in nowadays?
This is indeed the big question, or I would say the real bottleneck is indeed, do we have enough I would say, bandwidth in space for all what we plan. And thanks to our high priority, we may be on the lucky side. I have no clue if the big 3, 4, 5 constellations eat up everything. And if we have a high throughput connectivity, we use 500 megahertz of a band easily. So what do the others do? And we all use the same band, yeah? And then hopefully, and no one knows how it really will work. Yeah?
You moved to optical.
Pardon?
You moved to optical.
Well, it will come. And you are absolutely right. This limitation will automatically lead this, because this bottleneck, this is physics. Yeah, we cannot get more band. It's simply there, and I think the high priority helps us. But at the end, if I see where all the other big ones, look at Amazon, where Amazon is in the rows down the line somewhere. I have no clue how it shall work with them to coordinate with us. Yeah, over hot spots, so to say, and therefore. Are absolutely right. I'm pretty sure that we will maybe turn another medium sooner or later for the high throughput connectivity. Yeah.
Well, but specifically like the US, I mean, I know you talk about the ITU priority, but Elon Musk doesn't respect the SEC. I don't think he respects absolutely the ITU either. So, are you going to be able to provide service in the US?
No, it's true, absolutely true. This is the ITU, I always say, is more space to ground. But if you go from ground to space, then the ITU does not help you, so to say, and then you speak with, I would say, all the national regulators. No, we have not yet applied. We will we will come. This is a way we have to enter into it. We have our plan here in strong, I would say, in close coordination with our customers. We find out what is the best strategy here to deploy as soon as possible the services our customer like, and to concentrate on the markets we want to have. But yeah, the big thing is, of course, here to see how we enter into this, and more to come. And maybe our next round will come soon, and we will be part of it. Yeah.
And so let's turn a bit more to the applications of these new LEO networks. I mean, obviously, people have talked about the access networks that Starlink's providing, but where does latency, come into play? What are the key applications that need low latency? Are we going to find with these multi-orbit systems that we're splitting traffic so that certain applications go over LEO and others go over GEO? I mean, I think a big background question to that is, we've heard different stories. Is LEO a premium solution for a limited amount of traffic that needs that low latency? Or is LEO a cellular network that dumps lots of best efforts capacity into the market at a cheap rate and actually undercuts GEO? Or do we have both of those and they're just very different systems? So maybe, Ronald, do you want to start off on that, and we'll see where we go?
So indeed, when there's talk about LEO, latency comes up, but there's many more things. If you're in polar orbit, then ubiquity comes in play. We have lots of resiliency. There is security is like a story in and of itself. So so we shouldn't limit ourselves to latency. That's first. Second, when you say is it going to be this, that, or the other, it all depends on the architecture of the constellation. And here I go again. If you have a bunch of bent-pipe satellites, hundreds or thousands or tens of thousands, oblivious of each other's whereabouts, only looking for a gateway that they can dump traffic in when they've picked up something, because if they don't have a gateway in sight, they're basically useless. That's a very different type of constellation than the ones that we're talking about, where it's effectively a network in the sky with nodes, as Clemens put out. So the one constellation, the bent pipe constellation, it will be more in the last mile local tail type business, and that's basically all of our quote unquote competition, and that's a very price sensitive market. That's where prices have been going down for the past 20 years, from 3,000 to now almost under 100. So there are consequences for the type of architecture that you put in space. If you take the network approach that we do, you have more an ability to go into the high-end applications. And so you earlier talked about a switch, which in the context of that, for most would be an SD-WAN type of interface, whereby you have the ability to route traffic depending on the criticality for the enterprise or for the government that is sending or receiving that data. So SD-WAN is of critical importance to us. It will allow us to enter this enterprise market. I earlier talked about, antennas on the rooftops of enterprises, and such that, I want to make sure that people don't get the wrong impression. We're definitely not looking to take up all the traffic that these enterprises are sending back and forth, of course not. But these SD-WAN interfaces are going to be critically important for them to be able to decide to only send their high priority traffic that needs to be super secure and all that. And this is where latency comes into play if they want to run an ERP application over multiple offices that they have throughout the world, because then if you run an ERP application, you want to be under 200 milliseconds of latency, because otherwise the whole application will not run. Today, that's not possible, not with satellites, not with fiber, not with the best possible terrestrial infrastructure, because that's simply, in the current systems, both satellite and terrestrial, not possible. So we're looking to take that hurdle, because we can achieve those numbers. Does that mean that you're going to throw everything onto the satellite? Of course not. So this is where SD-WAN comes in. So from an application perspective, they will be very diverse. They will be different for gaming, they will be different for enterprise, they will be different for government. But all in all, there will be different applications from the one that are supported today with the satellites that we have up there in the current architecture. And I think that is important.
Mm-hmm. And Larry, I mean, obviously, is that what Inmarsat's looking for? Is a premium LEO to offload a limited amount of traffic to that really needs low latency, or is it the bulk dump your best efforts traffic onto this and you can't rely on it as much as your geos?
No, not at all. I mean, there's a future for GEO. We're launching an L-band satellite at the end of this month. I think it's the 28th. I saw this morning. We are launching the Arctic satellites I talked about. They're HEO, but they're not LEO. And we've got GX789, which is our Ka band and steerable mil-Ka band payload. So we believe in the future of GEO for sure. But we also have customers, as I said, who are demanding proliferated multi-frequency, multi-orbit networks. And we don't have the balance sheet to build our own LEO network, but quite frankly, there's no need to. There's going to be so much capacity in the market in a few years, and prices will be dropping. I hate to say that to you guys, but prices will have to come down.
For certain applications, they definitely will. Others, not so much.
And so we've decided, as again, I said, we're taking the approach of we're keeping our owned assets, but for like 5G mesh networks and hotspots, obviously we're going to get that capacity from the network from the local carriers. And then we're going to plug in a LEO component for those customers that require it.
Great. So we just have a few minutes left, so I just wanted to, run down the panel quickly, and maybe as a sort of way of closing out the day, maybe just let's ask the panelists, what they're most looking forward to over the next year, what they think they're going to achieve, and if we come back here in February 2024, what will have changed, and what successes will there be? What failures will there be, if you want to predict some of those too? Mate, why don't we start here?
Well, this year is clearly a big year for BridgeComm. We've been under contract with the Space Development Agency for the development of point-to-multipoint laser comm systems. So, for us, it's all about execution. What would I like to see? I would like to see lasers in space working as soon as possible.
Great. Larry?
Yeah, I mean, I mentioned the whole orchestra concept. For us, that's our future strategic direction. So what we need to do this year is make more progress on this hyper-intelligent software-defined WAN. If you're curious, we're working with Livewire right now to develop this. And then start pulling together the pieces that we don't control. So we control the GEO assets, we control the HEO assets, but we need to build out the 5G mesh, and then we need to enter partnerships with a LEO operator or operators to complete the orchestra concept.
And I assume we'll come back with a merged Inmarsat Viasat next year too.
And actually, I was waiting for that. Yeah, so we're waiting. It's going through the regulatory approvals. We're waiting for the UK competition, CMA, Competition Authority. And we're waiting on approval from the EU as well, and from the US, quite frankly. But that's all being worked, and we're fairly confident it's going to get through.
Ronald, the next year.
Give it a couple of days and you'll be fine, right? Yeah, so I think we're living in a world that's dominated largely by drama and sensation. So that's true for satellite. It's true for everywhere else. The headlines in the newspaper and what have you. So what I hope for next year is that a lot of the dust is settling. There's a lot of big names out there. Starlink was mentioned a couple of times, but for people to really think through the business cases and does it make sense and why does it make sense, and maybe it does not make as much sense as people think it does today. Because at the end of the day, the money will come from the customer, and if the customer is not prepared to pay, then business cases will fail, no matter how much money you put into it, being a billionaire or not. And so I wouldn't really want to see that people start focusing on the business cases. What customers are you going after? What problems are you solving? Does your system solve that problem for real? And are customers willing to come back to you and continue to pay for your services? I think that is important overall at the end of the day.
Vandal, any?
I look forward to hearing about more collaboration and partnerships between the LEO operators and teleports.
Clemens, last word?
Yeah, well, my objective is relatively clear. In 1 year from now, I have built up a complete supply chain with the Prime, and I'm pretty sure that we are already manufacturing the first satellites. And this is a big thing now for us, the industrialization of this manufacturing of 300 satellites in a row, or then maybe the other 300. And I'm happy to report next year about the status.
Great. Okay, well, thank you very much to the audience. Thank you for sticking with us. Go and get your drinks, and same to the panelists. Thank you very much.